Sometimes you want to add running totals to a query result, and SQL Server makes that very easy. Perhaps a bit too easy because there is a default that you absolutely need to be aware of. Let's look in detail at the over clause. The over clause is what makes, for instance, running totals and a lot of other things possible. So for running totals, you could, for instance, do this: the sum of a column, and then you specify that we need to reset when the customer ID column changes, and that within customer ID the data must be ordered by order date for the computation of the running totals. Here's how that looks. We have the same query here as a complete query, and when I run this query, you will see in the result, for instance, for customer ID 11,000, that if the query results are ordered by the same columns as the over clause, it's easy to verify that the data is correct. The running total for the first row is equal to the total due for the second row and the third row. You keep adding the new total due to increase the running total. And then on row 4, when the customer ID changes, we reset the running total and start again. All exactly as expected. So far, it all looks great. However, you may not be aware that we might have incorrect results and we might have bad performance. All of this is avoidable. So what exactly is the problem? And that is that we left out something. After the order by, we should have specified the so-called rows or range specification. We didn't. And because we didn't, we get incorrect results. Really? Yeah, really. Let's go back to the demo. And now if I scroll down a bit, oh, that's way too far. Let's use a different way. So here at row 223, you see something weird. The customer ID does not change compared to row 222. The total due is slightly below $40. But the running total is increased by $65. And then on row 224, it remains the same. Surely this is incorrect. This looks like a bug. Well, I'll get back to that, but let me first explain what's happening. So like I said, we are relying on a default here. And that default is the range specification range between unbounded preceding and current row. If you use an over clause or with an order by and with nothing else, then SQL Server will always assume that you meant a range between unbounded preceding and current row. Now, what exactly does this mean? Let's start with unbounded preceding. That means I want the sum of total due over all rows, starting with the very first row with the same partition, so with the same customer ID from the very first row based on this order by order date, and I want to end it at the current row. So we look at everything from the first row until the current row, and for the next row we add that current row. That is exactly what we want for running totals. So far it sounds good. However, there is also this keyword range. And what range means is if there is a tie in the order by column, then we consider all rows with the same order date as the same current row. So if I go back to the query results, if you look at row 223 and 224, they are considered they have the same order date, so they also are considered the same row. So even for row 223, the range specification range between unbounded preceding and current row ends at row 224 because it has the same order date and is hence also considered current row. That is a bit weird if you think about it in the English language, but it is how the range specification of the over clause has been defined in the SQL standard, and that definition has been embraced when Microsoft implemented it in T-SQL. So that means that even though we thought that the results were incorrect, they were actually correct, just unexpected. We didn't expect them because we thought that we specified real running totals. We didn't. We specified a functionality that is deliberately intended to return everything with the same order date as the same group. So, of course, we can fix this. If we want to use the range specification or just use the default, then you get these ties. The problem can be fixed by removing those ties. Now we get results that are expected. Let's look at this in the demo. So I'm going to add a key column, and it has to be a unique column for it to work. If this is also a combination of columns that still can have ties, we still have this problem. But the sales order ID is the primary key. So now I specify if there's multiple rows with the same order date, I'm still going to distinguish them, and they will never be the same range because they can't be duplicate. Of course, for the results to make sense, I have to make sure that I present the data in the same order as I use for this overclass. Otherwise, the final result could have the rows reversed, and then you still would get a very unexpected result. Now, if I run the same query, I don't know why it takes so long. Sometimes my system is a bit weird. Now we are. If I look at the same query and I go to this same data again, then you will see that at row 223 and 224, the data is now ordered by order date and the sales order ID, even though we don't see it in the results. And now the running total increases for each row. So we fixed the bad performance by making sure that the order by clause can never have duplicates. So far, so good. However, there is also one other problem, and that is that we can get bad performance. Let's look at that in the next demo. So I move to the other demo, and here I don't use the default. I have specified explicitly a range between unbounded preceding and current row, but again, that is the default. If I leave that out, I will get the exact same data. And I have added the sales order ID column to make everything unique. In the second example, where I use rows between unbounded preceding and current row, I also have included the sales order ID column, even though it's not necessary there anymore. When you use rows between unbounded preceding and current row, then even if there is a tie between the order by columns, only the actual current row is included in the running total. But I kept the sales order ID there to make the two queries comparable. So they're both correct, they will both give the expected results. And if I look at the execution plan, if you like to look at the percentages, you would think, hey, they perform the same, it's 50%. But of course, everyone who follows me knows that those percentages are basically useless. What I want you to look at is the runtime. So the runtime for the first query that used the range specification is 257 milliseconds. For the second query, it's only 67 milliseconds. Now, that performance difference is not caused by the right-hand side of the execution plan. If you look at the segment column, that is the execution plan of that segment column, and everything to the right of it, that's just about 30 milliseconds, and it's the same for both queries. There's no relevant difference there. But the window spool is where the difference is made. And the window spool is the operator that makes this overclass work. And for the range specification, you see that it took 4.5 times as much time as for the rows specification. Why is that? Well, that is because if you look at the comparison of these two, the Windows pool always needs a work table, but that work table can be stored on disk or in memory. And for this specific case, for running totals, a range specification will always store that work table on disk, whereas a row specification will keep it in memory. And that makes a huge difference. Of course, when I say on disk, it doesn't mean what actually writes to disk. It goes into the buffer pool. It might be flushed to disk. It's unlikely actually, but even storing things in the buffer pool for TempDB makes the query a lot slower, as you saw in the demo. So please, unless you need the functionality of the range clause because you need the same results for rows that have a tie in the order by column, in that case you obviously need the range clause. But if you don't, then never use the range clause. And that also means never use the default, because the default saves you some typing, but it gives you the default range clause. The only thing you should do when you need running totals is always specify rows between unbounded preceding and current row. And then the sales order ID tiebreaker column is not even actually needed anymore. If you really want to save typing, you can use a slightly different default. You can just type rows unbounded preceding, which means the same as rows between unbounded preceding and current row. Personally, I just type it all because that is more clear and specifies to everyone what you mean. This is, in my opinion, the only correct way to get running totals in your queries. I thank you for your attention to this short video. My name is Hugo Cornelis and I hope you liked this video. Bye bye.